All right, hello everyone. We are now into the second half of the statistics class. First half of this class, up until the midterm, we've learned all about different types of descriptive statistics. Now the second half of this class of 301 is laying the foundation for you to be able to do inferential statistics. That comes next semester for the sociology and criminal justice majors who have to take 302. For those of you who are social work majors and you don't have to take 302, although of course I encourage you to, the second half of 301 of this statistics class at least gives you the conceptual basis for what inferential statistics are about and how they work. And so we're really kind of starting this lesson in chapter 7 with the basis of doing inferential statistics and understanding research questions and hypotheses. And so, we left off with the first half of the class, ended with chapter 4, and we're kind of skipping a couple of chapters in the middle here because I think in my experience in the past that those fit better with 302. So we're jumping ahead to chapter 7, and you'll see there's a couple of things in this lesson that I plug in from chapter 6, so don't be alarmed if you did the chapter 7 reading, which I hope that you did. There's a couple of concepts that are introduced in this lesson that aren't in the reading, and that's okay. Okay, so when we say research hypothesis, what is this about? A hypothesis is an if-then statement of conjecture that relates variables to one another and is used to reflect the general problem statement or question that is the motivation or reason for asking a research question. It's basically an educated guess. And if we think about the process through which research is done with statistics, we start with a research question, we use that research question to develop a hypothesis, and then we, based off of that hypothesis, we'll learn then that that hypothesis determines what type of statistical technique we have to use. So that we'll get into, when we get to different types of hypotheses, you'll see that as we move into inferential statistics and into next semester, that hypothesis is so important because it dictates what is the appropriate statistical method to use. Okay, so let me start from an example. If our research question was something like comparing mean or average IQ scores, we could ask a research question that was based on gender and say, do females have a higher IQ than males? We could then present as a hypothesis to this that females have a higher IQ than males. In order to test this hypothesis, what would we do? If I tasked you with actually doing this study, you would go out and take a bunch of IQ tests with women and a bunch of IQ tests with men and take the average or the mean of those IQ tests and compare means. And so the way we set up hypotheses are about being able to make these comparisons of means, which we'll look at how to do that in a minute. Some helpful lingo, and this is one of the things that isn't covered in chapter 7 that's actually in chapter 6, but I think it fits much more usefully with this lesson, is the difference between dependent and independent variables. So when we look at a research question or look at a hypothesis, we know that there's at least two variables that are going to be in there. One is called the independent variable and one is called the dependent variable. The dependent variable is the thing that we're trying to see if it changes as a result of the independent variable. So the dependent variable, or the DV, is oftentimes also called the outcome or the predicted variable. We're looking at whether or not we see any change in this as a result of or due to the independent variable. The independent variable then is the thing that we think is influencing the dependent variable, that's causing the change in the dependent variable. So as I give you some practice problems, this last line at the bottom here is my kind of helpful cheat to be able to figure out which variable is the independent variable and which variable is the dependent variable. So anytime you have an example and there's two variables, use this little helpful tool that is blank influences blank, and you're plugging one variable into that first blank and one variable into that second blank. The first blank is always the independent variable, and the second blank is always the dependent variable. If it's helpful for you to think about the independent variable causes the dependent variable, you can think of it that way, but know that this is not necessarily a causal relationship when we look at the relationship between independent and dependent variables. But using this line, blank influences blank, where that first blank is always the independent variable, is helpful. So we can do a couple quick practice ones on these. I encourage you, if you want to take a minute and pause the video, read through these by yourself, or at least after maybe we do the first one together, you can practice by yourself for these other ones. But so I give you a bunch of different research questions here, and I want you to identify which variable is the independent variable and which variable is the dependent variable. And maybe for practice even, we can go back to the very first practice example I gave about hypothesis. And this hypothesis is females have a higher IQ than males, or the research question is, do females have a higher IQ than males? And we would have to identify what is the independent variable and what's the dependent variable. In this circumstance, gender, male, female, would be the independent variable, and IQ would be the dependent variable. We think that gender influences IQ. Remember, go back to that blank influences blank, where the first blank is the independent variable and the second blank is the dependent variable. So we would say gender influences IQ. That makes gender the independent variable and IQ the dependent variable. Again, take a pause, try to do these on your own. First question here is, does the number of beers you drink influence the number of times you burp? Go back to the blank influences blank. Here, our independent variable would be number of beers, and dependent variable would be number of burps. Here, we think that beers influence burps, so beers is independent, burps is dependent. Second question is there a relationship between getting sick and taking vitamins? Now the language is getting a little trickier. Ask yourself, blank influences blank. The independent variable in this one is getting sick, is taking vitamins. The independent variable is taking vitamins, and the dependent variable is getting sick. We think taking vitamins influences whether or not you get sick. Third question here is, are kids who play violent video games more likely to engage in violence? Ask yourself first, what are the two variables or things being studied in this question? We see that one of the things is playing violent video games or not, and the other thing is engaging in violence or not. Those are our two variables. Once you've identified what the two variables are, then you can pick which is the independent and which is the dependent. We think blank influences blank. Video games influence violence. So video games is our independent variable and violence is our dependent variable. Last question here is, are Black defendants more likely to receive longer prison sentences? For this one, our independent variable would be race, would be the race of the defendant, and the dependent variable would be sentence length. We think that race influences sentence length. So as you're getting, and we'll do lots of practice with these, so it's okay if you are unsure about them at this stage, but the steps for figuring out independent and dependent variables is, when you see a research question or a hypothesis, first try to identify what are the two things in that question that are being studied. Just pull out what are the two variables that are included, and then use the blank influences blank sentence, where the first blank is always your independent variable and the second blank is your dependent variable. And again, lots more practice to come on that. Okay, one key thing related to hypotheses as well is the difference between a sample and a population. And remember, this is somewhat of a review because we talked about this back in chapter 1 when we were talking about the differences between descriptive and inferential statistics. Inferential statistics are largely about using a sample to make inferences about the population. So in most circumstances, what we want to study, our population of interest, is bigger than we can actually study. And so we need to take a sample in order to study that population. However, we know that there's not always a perfectly representative sample, that the sample doesn't always perfectly match the population. This gap, or the difference between a sample and a population, is called here sampling error. And our goal is always to minimize the sampling error. We want our sample to represent the population as much as possible. If, however, the sample does accurately reflect the population, then we say the results have, our analyses have, a high degree of generalizability. Isn't that a fun word? We can say that the findings based off of our sample can be generalized to the population, to draw conclusions about the population as well. Okay, so this is jumping in now to the real crux of this lesson on setting up hypotheses. Again, we're doing no actual math or analyses in this lesson. That all that we're doing now is learning how to set up hypotheses. And the reason this is so important is because when we go later on to do the actual inferential statistics, we need to make sure we've set up the hypotheses in the correct way so that we pick the correct type of statistical analysis to conduct. Okay, null hypotheses. There's two different types of hypotheses for any research question or research statement you have. There will be one hypothesis that's called the null hypothesis, and then another hypothesis that's called the alternative hypothesis. So for any research statement, there's two hypotheses. One is the null, one is the alternative. The null hypothesis is always a statement of equality between the sets of variables. The null hypothesis is always that there is no relationship between the two variables being studied. In other words, if we're thinking about our blank influences blank, our independent variable influences the dependent variable, the null hypothesis is always that the independent variable does not influence the dependent variable. And the most important thing about hypotheses is now, when we have a research question, we need to be thinking about how would we actually do that study. And for the examples that we look at, it's all about comparing means, comparing averages. So if we go back to that very first example as one of the most simplistic ones, is there a difference in IQ based off of gender? Do females have a higher IQ than males? Again, how would you do that? You would compare the mean IQs for females to the mean IQ for males. If they were equal, that would mean that gender does not influence the dependent variable, right? That there is no relationship between the two variables. That would be the null hypothesis, is that there is no relationship between the two variables, that both means are equal. So for example, we could say if we had a research question that was about, is there a difference in mean test scores for 9th graders versus 12th graders? An example of a null hypothesis would be that the mean test scores for 9th graders and the mean test scores for 12th graders are equal, that they are the same. Alternatively, we could have a research question that asks, are there differences in recidivism rates for people who are released to a halfway house versus people who are released from prison to something called a day reporting center? The null hypothesis would be that both of these are equal. We could also ask a research question that's about, are there differences in flu rates for people in elementary school compared to college? And the null hypothesis, again, is always that the means for both groups are equal, that the mean flu rates for elementary school students are equal to the mean flu rates for college students. So if we wanted to practice, for example, also our independent and dependent variables here, in this first example, we would say that the grade level is the independent variable, test scores are the dependent variable. Is there a difference? Does grade level influence test scores? For the second one, place of release, halfway house versus day reporting center, would be our independent variable, and recidivism would be our dependent variable. Does type of center influence recidivism rates? Then for this third example, we would say school level, elementary or college, right, is our independent variable, and flu rates are our dependent variable. Does school level influence flu rates? So how do we set up the null hypothesis? There's something called a statistical notation for this, as well as sentence form. So the ones that I just gave you in these examples here are in sentence form. And what this is statistical notation. So oftentimes I will ask you to report both the null and the alternative hypothesis in statistical notation. That's this. I'll talk through this in a minute. It looks a little crazy, I know, as well as in sentence form. And although this statistical notation way looks a little crazy, it's actually much more helpful for understanding the different groups and can help you get to the sentence stage a lot easier. Okay, so what is each of these components actually representing here? So this H0 here, this HO, is what signifies this is the null hypothesis. There's a different notation, as we'll see in a minute, for the alternative. So this HO signifies that it's the null hypothesis. This kind of funky looking U is actually called mu, it's pronounced mu, M-U, and is the statistical notation for mean for the population, excuse me, mean for the sample. So our mu is the mean for the sample. We think the test scores for 9th grade equal the test scores for 12th grade. So this is the mean test scores for 9th grade equal the mean test scores for 12th grade. Again, the null hypothesis is always that there is no relationship between the variables. That if there's no relationship between the variables, that means that grade level does not influence test scores. How do we know that grade level doesn't influence test scores? Would be that the means for both groups are equal. And so that's what each of these categories represents. Oftentimes, if you're figuring out what to write in each of these spots, we are always making comparisons of means across the dependent variable. So we are always comparing means on the dependent variable for each group of the independent variable. So here our dependent variable in this example is test scores, right? Does grade level influence test scores? Grade level is our independent variable and test scores is our dependent variable. So you can always write first our HO colon mu for the dependent variable equals mu for the dependent variable, and then figure out how does your independent variable break down into different categories. Here our independent variable is grade level, and there's two categories of that independent variable, 9 and 12. So we know that that is what we're comparing on the dependent variable. Okay, so to do some other practices with this, and I kind of have this written out by hand so you can see how you would write it out in your own notes, not just based off of what's on the slides. But if I gave you a research question that was something like, are recidivism rates different for people released to a halfway house compared to a day reporting center, and asked you to give me the null hypothesis for that research question, we would know that the null hypothesis is always that the two groups are equal. So although I have here the sentence first on the slide, I actually think it's a lot easier for figuring out the answers to write it out in statistical notation first, because once you have the statistical notation, you can kind of create the sentence based off of that. So for the null hypothesis, remember you're always writing HO to indicate that that's the null hypothesis. And then this mu is the mean for the population. The mu is the mean, equals the mu is the mean as well. And we're comparing means for the dependent variable. Here, the dependent variable is recidivism rates, right? Does place of release influence recidivism rates? So place of release is our independent variable. Recidivism rates is the dependent variable. So our mu, the mean recidivism rates, equal the mean recidivism rates. And then we have to figure out how does the independent variable break down into two categories. Here it's recidivism rates for halfway house compared to recidivism rates for the day reporting center, with the understanding that our null is always a statement of equality, that there's the independent variable does not influence the dependent variable. If that's the case, it's because the means for both groups are equal. Our mean recidivism rates for halfway house and people released to a day reporting center are equal. Okay, other example I have here is the flu rates one. So if I gave you a research question or statement that was asking, is there a difference in flu rates for elementary school students compared to college students, and asked you to report the null and alternative hypotheses, we know that the null hypothesis is always a statement of equality, that their independent variable does not influence the dependent variable. So first step is to figure out what's the independent and what's the dependent variable. Here we're asking, does school level influence flu rates? So that first blank influences blank. That first blank is the independent variable. So school level is our independent variable, and flu rates is our dependent variable. When you're setting up your null hypothesis in statistical notation form, remember you can always do our HO mu equals mu, then write in what your dependent variable is on both sides, and then figure out how your independent variable breaks down into two categories. So here our two categories are elementary and college. So our mean flu rates for elementary equal to mean flu rates for college. And that's your null hypothesis. So null hypothesis is always, always, always that the means on the dependent variable for groups of the independent variable are equal. So some purposes of the null hypothesis. This is a starting point, right? If we have no other information about two variables, then you start from the assumption that there are no differences between the groups, right? And so this part about purposes is kind of background. I've said a couple times this semester, if you are one of the learners that you need to know why things work or the reason for them, listen in here. If you're the kind of learner for math and statistics that is just like, tell me the steps and what buttons to push, then feel free to check out for this slide. The idea of a benchmark is that we need to have no difference as a starting point, because even if there are differences that are observed in the sample, there's a good chance that the reason there are differences is just due to chance, just due to happenstance, that it's by accident. We can't necessarily say that it's due to the independent variable. So chance is all of the things that could cloud the picture, make it more difficult to understand the true relationship between variables in the population. So the null hypothesis is a statement of equality, is kind of like our starting point, right? Is our benchmark. We're starting from the assumption that there are no differences between groups, that the independent variable doesn't influence the dependent variable. In contrast, though, is the research hypothesis. The research hypothesis is also referred to as the alternative hypothesis, and this one says the independent variable does influence the dependent variable. This is now a statement of inequality between the two variables. So there's always, for any research statement, any question, a null hypothesis and an alternative hypothesis. For the alternative hypothesis, there's actually two choices. It can be either what's called non-directional or directional. So always two types of hypotheses, null and alternative. Within alternative hypotheses, there's two types of alternative, non-directional and directional. So I'll talk about the non-directional research or alternative hypothesis first. So this one, and while null is always that the two groups, the means are equal, alternative or research are always that they are not equal. Non-directional means that we don't know if one is, or we're not going to guess if one is greater than or less than the other, but we're just saying that the means are different or not equal to one another. So it posits that there's a difference between groups, but not in either direction. We're not guessing, for example, that mean test scores for 12th graders are higher than 9th graders. We don't have a sense of the direction of the relationship that one is greater than or less than. We're just saying we think that there's a difference in the means. So the mean test scores of 9th graders is different from the mean score of 12th graders. Same thing for this example. We don't think or have a guess about if recidivism rates are greater than or less than at halfway houses compared to day reporting centers. We just think that they are not equal, that they're different from one another. So how does this look? And I apologize too, I think it's correct, or I know that it's correct in your lesson handout that these X's should be X bars, but it's a real pain in the butt to get the X bar. I have to copy and paste in all the little pictures to get an X bar for the mean into the slide. So it's correct in your lesson handout, but just know on the slide here that this is supposed to be X bar, not just regular X, right? Where X bar signifies the mean. So statistical notation for non-directional research or alternative hypotheses. The first part that's different, remember for null, it was an H0. Now this is an H1. Sometimes you'll see it as an HA for alternative. I'll sometimes write it as HA, whichever you want to do is fine. Sometimes you'll see in actual scholarly journal articles or studies that you might read, they might list H1, H2, H3 because they have multiple research hypotheses. We won't get that fancy, but just if you're curious about where that one comes from, it just means the first of possibly several research hypotheses. For our purposes, if you like doing HA to remind you that that's alternative, feel free to do that, or H1. So our research hypothesis, our alternative hypothesis is H1, is X bar is the mean for the dependent variable is not equal to. So the key part here is what's in the middle is this equal sign crossed out, X bar, the mean test scores for 12th graders. So just like we do for the null hypothesis, you can copy the same exact thing for the research hypothesis. There's only two things that's changing. Instead of mu, that funky looking mu, instead of mu, you're using X bar, and the sign in the middle changes. So your null and alternative hypotheses will always match for statistical notation. The only thing that's different is you're writing H1 instead of H0, and you're using X bar instead of mu, and you're changing the sign in the middle. So that the sign here is this X bar is that it's not equal to, is what that means. All right, so let me give you these examples written out in sentence form as well as statistical notation. So if I gave you the research question that was, is there a difference in recidivism rates for halfway house release versus day reporting release? And your alternative hypothesis would be for non-directional, that it's H1 setting up, oh, and I apologize, I'm noticing now that this is an error. So this should be, I kind of cheated and just wrote in the cross out. This should be X bar here, not mu, my apologies. I'll post a correction for this. This is X bar, recidivism rates for halfway house do not equal recidivism rates for the day reporting center. So then the same thing for the flu rates and elementary college example, right? That this is the X bar for flu rates for elementary do not equal X bar flu rates for college. So it's all the same. You're using the same exact categories as you do for the null hypothesis. The only things that are changing is that it's H1 or HA instead of H0 like the null, and that this should be X bar, and your sign in the middle changes to signify that the alternative hypothesis is a statement of inequality. So for research or alternative hypothesis, it can be either non-directional or directional. What I just showed you was the example of it being non-directional, meaning we don't know which group is higher or lower than the other. We just think that there's a difference. And so for thinking that there's a difference between the two groups, that's when we use a directional research hypothesis. So this is a research hypothesis, an alternative hypothesis that says one group is less than or greater than the other. So if I gave you a research question that was framed in a way that says, are mean test scores for 9th graders less than mean test scores for 12th graders? This would signal that it's a directional research hypothesis because the research statement is making a guess about the direction of the relationship, right? We think that the 9th grader scores will be less than the 12th graders scores. Same thing for this other example with flu rates. If I gave you a research question that was, are flu rates higher for elementary school students than for college students? Our alternative hypothesis, our research hypothesis would be directional because we're making a guess about which group is greater than or less than the other. And here we're saying that we think mean flu rates are greater for elementary school students than college students. What does this look like in statistical notation for a directional research hypothesis? Again, this should be the X bar here. And so this is the same as non-directional. The only thing that's different is that this sign in the middle is no longer the does not equal to, but you have a couple of choices. It could be less than, it could be greater than, it could also be greater than or equal to, or less than or equal to. We won't, these ones get pretty complicated, the greater than or equal to and the less than or equal to. I want you to know that they exist, that that's a possibility, but all of the problems for hypotheses that I'll give you will just be using the less than or more than these top two, right? So depending on how the research question is worded, your research hypothesis will either be non-directional or directional. If it's directional, then you have to figure out, is the question asking or suggesting that one group is greater than or less than the other? And I apologize, I see now that when I was writing these out for you that I made the same mistake with writing mu instead of X bar. Here's where I miss being able to just write this on the whiteboard and fix it as soon as I see my error instead of having it here. But so again, for research hypotheses, this is X bar. I'll make sure this is right, corrected for all of the classwork problems, which I think I have it correct for the classwork problems. Okay, so this other example that we've been doing about recidivism based off of release location is our H1 signifies that it's non-directional. Our mu here, or this should be our X bar, is we're making comparisons across the dependent variable. We think that recidivism rates for halfway houses are greater than for day reporting centers. If I ask the research question, is are mean flu rates for elementary school students less than mean flu rates for college students? You would write your statistical notation out as the H1 is X bar, for the mean for flu rates for elementary is less than X bar, the mean flu rates for college. So that mean flu rates for elementary school students are less than mean flu rates for college students. I'm gonna then talk through some practice problems here. And so if you want to take a pause and make sure you want to practice this on your own before I give the answers, feel free to do that. I encourage you to do that. And this practice asks you to identify the null and alternative hypotheses in both statistical notation and sentence form. So the way these quote unquote problems will work is, again, you're never getting any actual math to do. This is all just practice in how do we identify independent and dependent variables so that we can set up our hypotheses appropriately. And this one then goes back to our research question on, do people who drink beer have a higher number of burps than people who don't drink beer? When you get a question like this, the first step is to always identify your independent and dependent variables. So use the blank influences blank trick if that's useful for you. Here we know that the two variables we're looking at, the two things we're studying, are number of burps and drinking beer. Would it make sense to say, does burps influence drinking beer? No, that's not what we're studying. Does it make sense that this question is asking, does drinking beer influence burps? Yes, right? So then drinking beer or not is our independent variable, and number of burps is our dependent variable. So for the blank influences blank, sorry, that pressed that button to give you the answer too quickly. So our independent variable is beer drinking, dependent variable is burps. Then we know for the null hypothesis is our next step. And to set up the null hypothesis, you always start first, just write out your HO is the statistical notation for null, colon, our mean for the null hypothesis is mu, this kind of funky looking mu. Write that out first, equals mu. Null hypothesis is always, always, always an equal sign here. Then to figure out what your two groups are, what are we comparing the mean on? We're comparing the mean on the dependent variable. We're comparing the mean on the dependent variable. So first write number of burps or whatever your dependent variable is for both sides, and then think about how does your independent variable break down into two different groups. Here, based off of our research question, our independent variable is beer drinking. So we have beer drinkers and non-beer drinkers. So we're comparing the dependent variable for each of the two groups of the independent variable. So our null hypothesis is that the mean number of burps for beer drinkers is equal to the mean number of burps for non-beer drinkers. That's your null hypothesis. So go through the steps of always write out first your HO, your mu equals your mu. First line is the dependent variable on both sides. Second line then is how the independent variable breaks down into two groups. If that's helpful to go through those steps for how to set up your null hypothesis. Other people, it works easy to think, it works better for them to just think, okay, if I was going to do this study, how would I do that, right? If I was going to study, do people who drink beer have a higher number of burps than people who don't drink beer? I would look at what's the average number of burps for people who drink beer and compare that to the average number of burps for people who don't drink beer. If it's helpful for you to start from that conceptually, how would I do this study, and then write out your groups, do it however works for you. But if you want to go through the steps are always, always, always for null. Your mu equals mu on the dependent variable for your two groups of the independent variable. Then to develop your alternative hypothesis, you can go for it and always set it up with the H1, your X bar, and your X bar, and your categories here for the alternative hypothesis are always, always, always going to be the same as the categories for the null hypothesis. All you need to figure out what changes for the alternative hypothesis compared to the null is what the sign in the middle is. Here, we have to look at how the research question is worded to determine if it's directional or non-directional. So we can ask ourselves, is there something about the way this question is worded that suggests one group is higher or lower than the other? And our answer is yes, right? This is saying, do people who drink beer have a higher number of burps than people who don't drink beer? So depending on how the research question is worded, you determine if it's directional or non-directional. This is here directional because we're saying that we think one group is less than or greater than the other. If instead the question here was worded as, is there a difference in the number of burps for beer drinkers versus non-beer drinkers, then this would just be is not equal to. So I have that as kind of the as the opposite example here in the alternative hypothesis, just to have that as an example, right? That you would say the mean number of burps for beer drinkers is not equal to the mean number of burps for non-beer drinkers. That would be if this question is worded differently. If we were having this match here, we would say the mean number of burps for beer drinkers is greater than the number of burps for non-beer drinkers. I just wanted to give you an example for this same one if the research question was worded as a non-directional one, which this research question is worded as directional because it's saying one group is higher than the other. Last practice one then is to ask, are kids who play violent video games equally likely to have the same number of violent acts compared to kids who don't play violent video games? So again, start from the point of ask yourself, what are the two variables, what are the two things being studied? Here, one of them is video games, right? Playing violent video games or not. And the other thing being studied is violent acts. Use the blank influences blank to figure out which is the independent and which is the dependent. Here, our independent variable is playing violent video games or not, and our dependent variable is the number of violent acts, is violence. We think video games influence violence. Null hypothesis, remember, is always a statement of equality. So start by setting it up with your HO, is your mu, that's your mean, equals your mu. Fill in what's your dependent variable on both sides, and then how your independent variable breaks down into the two groups. So we're comparing the mean number of violent acts for video gamers is equal to the mean number of violent acts for non-video gamers. We're saying that these two groups are equal. That's your null. To set up your alternative hypothesis, you're doing the same exact thing as above. You're just changing this to an H1. You're using X bar instead of mu. These categories stay exactly the same as they are for the null. The only thing that changes is the sign in the middle. So you need to figure out, based off of the way the research question is worded, what goes in the middle here for this sign. For null, we know it's always, always, always equal. For our research hypothesis or our alternative hypothesis, we know that we have to figure out what this sign is based off of the way the research question is worded. Is there anything in this question that suggests one of these groups is greater than or less than the other? And the answer is no, right? This one just asks, are kids who play violent video games equally likely to have the same number of violent acts? Equally likely means we don't know, is there one greater than or less than the other? So this is a non-directional research hypothesis. We're just saying that the two groups do not equal. If instead this one had said, are kids who play violent video games more likely to have the same number of violent acts compared to kids who don't play violent video games? If this equally was more, then this would be a greater than symbol here, and it would be a directional research hypothesis, right? So our alternative hypothesis here is that the mean number of violent acts for video gamers is not equal to the mean number of violent acts for non-video gamers. Okay, I hope we're starting to get the general idea of this. Again, this is one that takes lots of practice. So I know there's no actual math this week, which is good, but this is still tricky concepts for people to get. So we'll have lots of practice still to come in the classwork. Don't worry if you're still feeling a little confused. So just like for all of the other lessons, I remind you, by the end of the lesson with me, I expect you to kind of be in the meh stage. By the time you get through doing the classwork, you'll feel more confident about it. So stay tuned For that, I will talk to you guys soon. Take care.